students. Today I am going to represent representation of discrete time signal and classification of discrete time signal. So first of all, let's take an example of discrete time signal. Example: if x of n is equal to x of minus 3, x of minus 2, x of minus 1, x of 0 is equal to 4, 3, 2, 1 and 0. So the diagram is represent like here n is the representation of n, that is minus 3, minus 2, minus 1 and 0, and that is the value of x of n. That is the value of x of n. So x of minus 3 is 3. So x of minus 3 is 3. And the x of minus 2 is 2. So x of minus 2 is 2. And the x of minus 1 is 1. The x of minus 1 is 1. And x of 0 is 0. So that is the representation of discrete time signal. We can represent the discrete time signal in various ways, like in graphical form, in tabular form, in functional form, and also in sequential form. So today our topic is classification of discrete time signal. So the classification of discrete time signal, it is divided into 4 types: casual, non-casual, symmetric, skew symmetric, and power signal, energy signal, periodic signal and non-periodic signal. So first of all, we are going to start casual and non-casual signal. Casual and non-casual signal. So what is casual signal? The signal x of n is said to be a casual signal if its all values is 0 for n less than 0. The signal is said to be casual signal. X of n is said to be casual signal if its all value is 0 for n less than 0. Let's take an example. X of n is equal to 1, 2, 3, 4 and it is start from 1. So here you can see that if you are doing represented in graphical form, it's like 0, 1, 2, 3, 4. In 0 it is 1, in 1 it is 2, in 2 it is 3, in 4 it is 4. Sorry, in 3 it is 4. So that is the graphical representation of casual signal. Here you can see that the value is 0 for n less than 0. For n less than 0, its value is 0. So you see that is a casual signal. That is the example of casual signal. Otherwise it is non-casual. Otherwise it is non-casual. So what is non-casual? In non-casual, we can get the value in 0, in 1 and also in minus 1. Means here we can get the values in the negative portion also. So it is 1, it is 2, it is 3. Like it is 1, 2, 3. And in the sequential representation, we know that we have put arrow mark in 0. So in 2, we are putting a 0 when the value of x of n is 2 in 0. So we put arrow mark in 2. So that signal is non-casual signal and that signal is casual signal. So here we can compare that in casual signal, all values of the negative portion is always 0 and never get any value in the negative portion. But in non-casual signal, we are getting the values in positive portion and also in negative portion. The next is periodic and non-periodic signal. In periodic signal, what happened in periodic signal? In periodic signal, we can see that the signal x of n is said to be the periodic signal if it satisfies the condition x of n plus n is equal to x of n for all values of n. If it satisfies that condition, then the signal is known as periodic signal. So how to satisfy this condition? Let's take an example in graphical form. So here you can see that is minus 4, n is minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3 and 4. And here where repeatedly the signal is repeat, means it is 4, 3, 2, again it is repeat, 4, 3, 2, again it is repeat, 4, 3, 2. Means here we can observe that the same sequence is repeatedly again and again. The sequence is 4, 3, 2, 4, 3, 2, 4, 3, 2. So we can find out the period. What is the period? The n is 3. Means the 4, 3, 2. The same sequence is repeated again and again. So the period is 3. If we are repeated 4, 3, 2 and 1, again 4, 3, 2 and 1, 4, 3, 2 and 1, that means the n is 4. So here you can see that is a periodic signal, that means a constant period repeatedly again and again. So the capital N is 3, where it satisfies that conditions that like n equal to minus 3, n equal to, let n equal to minus 3, and we know that capital N is 3. So x of n plus capital N, that means the n is minus 3 and the capital N is 3, that means x of 0. So what is the value of x of 0? X of 0 is 3. So here we can observe that in x of n plus n is 3. X of n plus n is 3. And here x of n. And here we are taking n equal to minus 3. So x of minus 3. So the value of x of minus 3 is also 3. That means here we can observe that we are satisfying these conditions. If we are satisfying the condition x of n plus n is equal to x of n, then that signal is known as periodic signal. What is aperiodic signal? Otherwise it is aperiodic signal. Means in aperiodic signal, the example is it never continue a normal sequence, a constant sequence. That means like 1, it is 1, 2, 3, then again it is 3, then again it is 1, again it is 4. That means it never continue a constant sequence. That is known as aperiodic signal. If it does not follow it, if it does not satisfy this condition, then the signal is known as aperiodic signal. So first we are discuss about casual and non-casual signal. Then again we are coming to the topic aperiodic signal. In aperiodic signal, we define the condition. A signal is said to be aperiodic signal if it satisfies the condition x of n plus n is equal to x of n. And that is the example of aperiodic signal. In example, we are satisfying these conditions where we are taking n equal to minus 3. The condition is x of n plus n. So n equal to minus 3 and capital N is equal to 3. So its value is x of 0, and we check that the value of x of n plus n and x of n is 3. Next, coming to the next point. Our next point is even and odd signal. Even and odd signal. Otherwise it is known as symmetric and asymmetric signal or skew symmetric signal. So even signal, a signal x of n is said to be even signal if it is satisfies the condition x of minus n is equal to x of n. A signal is known as even signal if it is satisfies the conditions x of minus n is equal to x of n. Let's take an example in graphical form. Here it is -3, -2, -1, 0, 1, 2 and 3. If n is 3, then 3 is in -3. If its value is 3, in 3 it is also 3. In -2, if its value is 1, then in 2 it is also 1. In -1, if its value is 2, in 1 it also have 2. That means what? That means what? It satisfies that conditions x of -n is equal to x of n. X of -n means what? Let n equal to -3. So x of -n means x of -3, and x of n means 3. X of -n is equal to x of n. Here you can see that it having same values like 3. Clear? So it satisfies the condition x of -n is equal to x of n. Similarly, x of -2 is equal to x of 2 is equal to x. In x of -2 it have values 1, and also 2 it have values 1. So it is 1. In x of -1 equal to x of 1, it is also having values 1. Sorry, 2. So that is the example of even signal. Let's take an example of odd signal. In odd signal, the condition is x of -n is equal to -x of n. In odd signal, we are taking an example. X of -n is equal to -x of n. That is the condition for odd signal. Let's take an example of graphical. Take an example in graphical form. If -2, -1, 0, 1 and 2. In -2, if its value is 2, then in 2 its value is -2. That is the difference in even signal and odd signal. In even signal, here you can see that x of -n is equal to x of n. In odd signal, x of -n is equal to -x of n. That means if its -2 value is 2, then -x of n its value is -2. If it is 3, in -1, then it is 1, it is -3. And if its value is -3, in -1 if its value is -3, then in 1 its value is 3. That's why it satisfies that conditions. Here you can see that x of -n means x of -2 is equal to -x of n minus x of 2. Minus x of 2 means what? Minus its value is -2. Here you can see that it has same values. X of -n it values 2, and x of 2 it values as -2. So that is the difference between even signal and odd signal. First of all, we will discuss about casual and non-casual. Secondly, we will discuss about periodic and aperiodic signal, and now we will discuss about even and odd signal. And the last one is your energy and power signal. Energy and power signal. The energy signal is defined as E of n. The energy signal is defined as E of n, and we can find the energy of the signal by the formula summation of n is equal to -∞ to ∞ x of n mod square. That is the formula to find the energy of the signal. And the power signal is defined as P of n. Then the power signal formula is E mean n tends to infinity 1 by 2n plus 1 summation of n equals to minus n2 plus n x of n mod square. So that is the formula to find the energy signal, and that is the formula to find the power signal. By using this formula, we can find the energy and the power of the signal. So that is the classification of discrete type signal. Let's take an example of a signal and we'll test whether it is a symmetric signal or asymmetric signal, even signal or odd signal. Let's take an example. Already we have discussed about that. The condition for even signal is x of minus n is equal to x of n. That is the condition for even signal. So here we can change that is even signal or not. Even signal or not. If we are considering these questions, then x of minus n is equal to x of n. So in x of minus 3, its value is 3, and x of 3, its value is 4. So it is not satisfied that conditions. X of minus 3 is equal to 2, x of 2 is equal to 2. That satisfies that conditions. X of minus 1 is equal to 1, x of 1 is equal to 3. That is also not satisfied with conditions. That is also not satisfied with condition. That means from the above we conclude that is not an even signal. So if it is not an even signal, we can check that whether it is odd signal or not. Whether it is odd signal or not. What is the condition for odd signal? For odd signal, the condition is x of minus n is equal to minus x of n. If in x of minus 3, its value is 3, then in x of 3, its value is minus 3, but it doesn't. So that means it is also not a odd signal. Let's take another example. And then is 0, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. Here we are checking that whether it is periodic signal, or aperiodic signal. Whether it is periodic signal or aperiodic signal. If it is periodic signal, then it satisfies the condition x of n plus n is equal to x of n. If it is aperiodic signal, it is satisfies the condition x of, otherwise it is aperiodic. If it is also satisfied that condition, then it is aperiodic signal. So let's check that x of n plus n is equal to x of n. It satisfies that conditions or not. So what is the period in that signal? What is the period? N is equal to, observe that is 3 2 1 3 2 1 3 2 2, 1. The same sequence is repeat again and again. That means here the period is 3. And if n is equal to 3, if n is equal to 3, then x of n plus capital N. N plus capital N means n equal to 3. N equal to, we are taking n equal to 3. So n equal to 3 and its value is 3. Let n equal to 0. If n equal to 0, that means x of small n is equal to 0 we are taking, and capital N is equal to 3. So 0 plus 3 is equal to x of 3. X of 3 and n equal to 0. X of n plus n is equal to, we are finding x of 3, and x of n is equal to 0, then x of 0. That means if it is periodic, then it satisfies the condition x of 3 equal to x of 0. So x of 3 is equal to 2 and x of 0 is equal to 2. That means x of 3 equal to x of 0 equal to 2. That means it satisfies the condition x of n plus n equal to x of n. That means it is periodic signal. That is a periodic